Okay, so we're going to finish off 3.6, looking at rational inequalities. Last class we finished, or we left off with quadratic inequalities and polynomial inequalities. So here we're looking at rational inequalities. Make that in better. So it's very similar to what we did last class as far as rational inequalities are concerned. Here we have x plus 3 over x minus 7 is less than 0. All right. So we always want to set one side equal to 0, just like before, because we want to do our comparison to 0. Remember, if it's less than 0, then we're talking about negative. If it's greater than 0, talking about positive. Also, we have our less than symbol, so that means we're going to use parentheses. That's why I have that symbol right there. If it was less than or equal to, then we'll be using the bracket. So all of those things still hold true. So we're going to set the numerator and denominator equal to 0 to establish our intervals, just like we did last session. So x plus 3 equal to 0 gives us negative 3. X minus 7 equal to 0 gives us positive 7. And those are our intervals. And let me erase this. All right, so we set up our table the same way we did last class. We have our intervals, test values, and then the behavior of the graph. Behavior. All right. First interval is negative infinity to negative 3. Then we're looking at negative 3 to 7. And then 7 to positive infinity. All right, make sure we're okay before I keep going. So once again, these two values help us to set our intervals for when our expression run across 0. All right. So we're going to use, on our infinity signs, we always use parentheses. And then, as I mentioned before, it's less than. So that means we'll use parentheses on negative 7 and 7. And negative 3, excuse me, and 7. All right. Now we need our test values. Just anything or any number that's in that interval. So anything less than negative 3. Anything in between negative 3 and 7. And anything greater than 7. All right. So now we plug those values and erase this. All right, so we plug those values, those test values, into our expression. X plus 3 over x minus 7. All right, plugging in negative 4. That's negative 4 plus 3 over negative 4 minus 7. So that ends up giving me a negative over a negative, which is a positive result. And plugging in 0 right here. That gives me a positive 3 over negative 7. Positive over negative gives me a negative result. And then plugging in positive 8 gives me positive over positive, which is a positive result. So, any questions? Any questions? All right, so we want to know, when was this expression less than 0? That's right here. So our interval is going to be -3 to 7. All right. Any questions? Any questions? So we'll do at least one more. Scroll up. Everybody good? All right, magnify. All right, so the next one, x plus 3 over x, x plus 1 over x plus 3 is greater than or equal to 2. So the first thing we notice is that we have 2 on one side of our equation, and we need 0. So we need to set one side equal to 0, and we'll do that by subtracting 2 from both sides so that they cancel out on the right. All right. So now, if I want to combine this, remember whenever you have fractions, in order to add or subtract fractions, you need a common denominator. So our common denominator will be the x plus 3. So I'm going to multiply that to the top and bottom. All right. So be careful here. Make sure that this minus sign stays with the 2, so that when I do this distribution right here, it's distributed with the 2 as well. So because I have common denominators, I can now bring it together. So that's what I did here. Distribute -2. So now I have minus 2x minus 6. So combine your like terms. That's x plus 1 minus 2x minus 6 gives me -x minus 5 in my numerator. And this is our new expression. So our new expression right here. -x minus 5 over x plus 3 is greater than or equal to 0. The or equal to reminds us that we're going to have to use brackets. All right, make sure we're okay. All right. We'll come back to this statement in a second. But just like before, you set you set the numerator and denominator equal to 0, so we can establish our intervals. So we can establish our intervals. So -x minus 5 equal to 0. Solving for x, you'll get x equal to -5. X plus 3 equal to 0. You'll get x equal to -3. So from here, we'll set up our intervals. All right. So the first interval, negative infinity to -5, -5 to -3, and then -3 to infinity. Negative infinity and infinity will always have parentheses. Negative infinity, infinity will always take on parentheses. Now, because we have these brackets, because we have or equal to, we're supposed to use brackets. So now, in this case, we have to be careful because we cannot use bracket on both numbers. And that's because our denominator cannot be equal to 0. So when we set and we found this value right here, this is when the denominator is equal to 0. But remember when you talk about fractions, you can't have a fraction equal to 0 in its denominator. So that value cannot be included. When we look at what we get from right here, that cannot be equal to 0, that cannot be included. So I would actually use brackets on the -5 because that can be 0. 0 in your numerator is fine, but I cannot use bracket on the -3. I have to use parentheses. All right, so you just have to be careful with that when dealing with rational expressions. You use bracket on the value that you get out of the numerator, but use parentheses for the number that you get out of the denominator. All right, so from there, test values, we can use -6, here -4, and here we can use 0. Let's see what values I use. 6, -4, 0, okay. And so plug it into your expression. Plug those 3 values into your expression. So be careful with this negative. You know, you plug it in -6 and you have a negative sitting on the outside of your expression. Okay. So here we plug in -6. That ends up giving us a positive number over a negative number, which is negative. Here, plugging in -4, we end up getting a negative over negative, which is a positive result. And then plugging in 0, we get a negative number over a positive number, which it gives us a negative result. All right. Any questions? All right, so we go back and analyze our chart. We want to know when is this expression greater than or equal to. So that's right here. So our solution would be -5 to -3, bracket over 5. Parentheses over that 3. All right. Questions? Any questions? All right. We good to go? go to look at 3.7. All right. All right, 3.7. So we're looking at modeling using variation. So what's going to happen here is that when doing these type of problems, you're going to have key phrases that will let you know how to set up the problem. And yes, you can use other ways of solving these equations, but this is just showing the way you can do it through these variation problems, this variation setup. So just throwing it out there because I know people have asked that in the past. Well, couldn't you solve it doing such and such? Yes, you do. There are other ways of solving these problems, but this is showing you this method using variation. So the first one is direct variation. So notice the key phrase here, y varies directly as x, or y is directly proportional to x. That prompts you to set it up this way. Y equal to kx, where k is the constant of variation. So k is always going to be a part of all of these variation problems. That's going to be a constant of variation. So when we go about picking out our variables, we can use any variable to represent our missing pieces or whatever it is you're trying to solve for. Just remember that you do not want to use k because k is your constant of variation. So in other words, let's say if you're dealing with a problem that has kinetic energy involved, then you wouldn't use k for kinetic energy, you would just use E. So just throwing that out there. Oh, also notice the phrase varies directly as. So whatever comes before varies is your y. What comes after as is your x. Same thing here. Whatever comes before the phrasing is your y. What comes after it is your x. And then you'll set up the problem this way. Okay. So we have the distance that a body falls from rest. Wrote that from better. From rest varies directly as the square of time, square of the time of fall. The skydivers fall 64 feet in 2 seconds. How far will they fall in 4.5 seconds? So all of these are going to be set up the same way. They give you a phrase, a key phrase to let you know how you're going to set up the problem. They're going to give you enough information for one relationship, then you're going to be missing one piece of the other relationship, then you'll be able to solve for it. So all of them will be set up the same way in this section. So I've got it written down in steps. So the first thing we want to do is identify the variation setup. It says varies directly as. All right. So we're using our direct variation. Then we want to establish our variables. So it says the distance that a body falls from rest varies. So that is our y. Remember, whatever comes before varies or comes before your phrasing is your y. Then it says that varies directly as the square of the time of fall. All right. So then that means our time should be the x. We'll take the place in x. So I'm calling d for distance, t for time. All right, then we write the equation, put them in their proper position. Distance came first, so that's going to come before the equal sign. Time came afterwards, so that comes after your k. But not just the time, but the square of the time. So that's why I have d equal to kt squared. All right. Next, I say right now you're given information. So there's always going to be a first set of information, then a second set of information that's going to be missing one piece. So that's what we have here. Your first distance is 64 feet, and your first time that correlates to that 64 feet is 2 seconds. And it dropped 64 feet in 2 seconds. Then it says how far will they fall? So that's your second distance in 4.5 seconds. So we need to solve for that second distance. So next we're going to use the equation in the first set of information to find K, the constant of variation. Remember, this is it's called constant variation because it's going to be constant throughout this whole problem. So we're going to substitute D and T into the equation. That's what we did right here. D1 and T1 into the equation. So the 64 equal to K times 2 squared. 2 squared is 4, so 64 is equal to 4K. Divide by 4, this means that K is equal to 16.
Could you leave it there for a second?
Mm-hmm. Well, I didn't even know all you guys came in. I was just still thinking it was just one person. Y'all should say hey or something.
Okay, thank you.
Yep, not a problem. All right. So we have K, and now we can put K into the equation because remember that's your constant of variation. That K is going to stay the same throughout the rest of the problem. So now we have D is equal to 16T squared. Now we use the second set of info and this new equation that has 16 in it to find the missing piece. All right, so we're looking for D2, and we can do 16 times 4.5 squared. 4.5 squared is 20.25. Multiply that times 16, and that's how far they will fall in 4.5 seconds. All right, questions where we look at inverse variation. All right, so inverse variation, very similar to direct variation, is just that inverse variation has this setup. So y varies inversely as x or is inversely proportional to x is going to be y equal to k over x. All right. So next problem. I could have left that one. Says when you use a spray can and press the valve at the top, you decrease the pressure of the gas in the can. In general, if the temperature is constant, the pressure of a gas in a container varies inversely as the volume of the container. How much more is up there? Okay. Give you a chance to write that for those who want to write it. Then I'll scroll down. All right. In general, if the temperature is constant, the pressure of a gas in a container varies inversely as the volume of the container. The pressure of a gas sample in a container whose volume is 8 cubic inches, excuse me, and is 12 pounds per square inch. If the sample expands to a volume of 22 cubic inches, what is the new pressure of the gas? All right. Okay, first step is to find the key phrase, and that's inversely. So that's going to have us, yep, still have my eraser on. That's going to have us set up our problem, y equal to k over x. All right. So we need to establish what those variables are. So we look at our phrasing, varies inversely as, and what comes in front of varies is going to be our y, or our first variable. And it says if the temperature is constant, the pressure of a gas in a container varies. So the pressure of the gas is going to be our first letter. And then after varies inversely, the volume of the container is going to be the other variable. So that's what we have right here. P for pressure, V for volume. All right. So we'll set it up this way. P is equal to K over V. P came before your phrasing, V came afterwards. Write down given information as far as your numbers are concerned. So P1 is 12, V1 is 8, and that comes from right here. Volume is 8, and then our pressure is 12. And it says, what is the pressure? The volume is 22. All right. So take our formula, plug in the first P and V to figure out what K is. That's what we're doing right here in the fifth step. So 12 is P, V is 8. Multiply both sides by 8. That gives me K. That's 96. So that's what is reflected in step 6. K being 96. Remember, that's our constant of variation. So that K is going to stay the same as we progress throughout this problem. So now we look at P2 and V2, our second pressure and our second volume. Remember, we want to know what's the pressure when the volume is 22. So we plug in 22, and that gives us what the pressure would be. All right, questions, any questions? All right, let's look at another one. Combined variation is when more than one variation is used. Sample of, let's see. Oh yeah, joint variation is when it says y varies jointly as x and z. Somebody say something in the chat. Oh, that's fine. It's all good. Not a problem at all. Thanks for letting me know. So you see how we set up joint variation. Y equal to k times x times z. Trying to think, did the next one have combined variation? Jointly. I think they mentioned this, but I didn't see one that involved combined variation. But of course, if you see one, you have a question about it, then feel free to bring it to class or shoot me that email. But they go into joint variation next. All right, so let me. Oh, okay, yeah, this one involves joint variation. I think we used this. I made this one up. Yep. Okay, I put one in here. All right, anybody still copying joint before I scroll up? All right. So the centrifugal force of a body moving in a circle varies jointly with radius of the circular path and the body's mass, and inversely with the square of the time it takes to move about one full circle. One full circle. A 6-gram body moving in a circle with radius 100 centimeters at a rate of 1 revolution in 2 seconds has a centrifugal force of 6,000 dynes. I'll stop right there. What you guys write? All right. So find the centrifugal force of an 18-gram body moving in a circle with radius of 100 centimeters at a rate of 1 revolution in a second. All right. So we have two key phrases that we have to give account for. Varies jointly and varies inversely. All right. So let's look at the key phrases here. We have varies jointly and then inversely. So we have the centrifugal force of a body moving in a circle varies jointly. So centrifugal force is our first phrase. First variable. So I use C for centrifugal force. All right. It varies jointly with the radius of the circle and the body's mass. All right. And then it varies inversely with the square of the time. And so that's what we have right here as far as our letters are concerned. Centrifugal force, radius, mass, and time.
Like 2 lines. I'm still trying to copy it down. Thank you.
Not a problem. All right, we okay, scroll up a little. All right, so this is how we set up the problem right here. So remember, it varies jointly with the radius and the mass, and then inversely with the square of the time. So your joint setup has us doing it, multiplying these two up top, and then the inverse setup has us dividing by t squared. Any problems? All right. Hold on. Are we done copying black?
Yeah, I'm all good. Thank you.
Okay. Cool. All right. So, given information, all the information that we know. First centrifugal force 6,000. First radius 100. First mass is 6. First time is 2. And it asks us what is the centrifugal force? If the radius is 100, mass is 18, and the time is 3. All right, so we take all of the first information, plug it into this formula right here to find K. All right, don't let me scroll up too far. Okay. So 6,000 is equal to K times 100 times 6 over 2 squared. So if you were to simplify all that, that would give you 150. So that's why I have 6,000 equal to 150K. Divide by 150, K is equal to 40. All right. So our new formula, C is equal to 40 RM over T squared. And now we'll plug in our second set of information to find our second centrifugal force. So we already have 40 for K, plug in 100 for R, 18 for M, and then 3 for T. Simplify that, you get 8,000. So 8,000 dimes. All right, questions on that? All right, so that's it for chapter 3. Next class will be an opportunity for you to ask whatever questions you want to ask. Basically a review day. You can, what I would suggest is that you at least take a look at the review, the test review, and go in there and see if there are any questions you want me to take care of. So problems that you may not be comfortable with or just want to see me do, or whatever the case may be, bring them to class so we can knock them out. But if you're good, you're good. You know, I'm not saying you got to bring a problem to class, but next class will be your opportunity to get those questions in. All right. Any questions or concerns before we close out? Make sure we're okay. All right. So, like I said, that's it for chapter 3. Next class we'll be reviewing. We will be reviewing and go from there. So, you guys have a good one. Be safe, and I will see you on Wednesday.
Thank you.
Thank you.